Right, this is an extra example on properties, example on properties of probabilities. We have those 6 properties in the lecture. I hope you watched the video. Uh, and we can use those properties to calculate probability sometimes when it's difficult to calculate in the other way. Uh, so for example, I have here a game or a drawing, if you like, in which I would have a hat or a box with 3 balls. 2 of them are red, 1 of them is black. So I have a black ball here and I have 2 red balls here. Now, if I draw at random, so without watching, right, or from a closed box, 2 balls, I could get 2 red, I could get 1 red and 1 black. Okay, now what is the chance that I'm going to get either of that? So if I can answer what is the chance that I'm going to get 1 black and 1 red, then I will know what is the chance to get 2 reds, because it's just going to be complementary probability, right? Or I can answer what is the chance that I'm going to get 2 red, and then I will know what is the chance I'm going to get 1 red and 1 black, because that will be complementary. One of the two will happen, but not both, right? So let's answer this question. What is the chance that 1 will be red and 1 will be black? Okay, so I'm asking a question, 1 red and 1 black, what is the chance? Okay, you can split this into 2 events. This is a single event, 1 red and 1 black at the end, right? You can split it into 2 events. One would be first ball is red and the second ball is black. That's one way to get the red and black. Or the first ball is black and the second one is red. So when you're drawing, you draw the first ball, and the first ball could be either black or red, and the second ball then it's going to be the opposite color, because that's what we want to get. We want to go 1 red and 1 black. So it could be the first ball is red and the second is black, or the first black and the second is red. That means that 1 is red and 1 is black, right? So using the property number 3, which talks about the property number 3, says if you have first red and second black, and or first black and second red, those are 2 mutually exclusive events. You can either have a first black or red. You can't have both, right? So these are 2 mutually exclusive events. So the first event is first ball is black and the second one is red, and the second event is first ball is black, first ball is red and the second one is black. 2 different things. Okay, so this property says A or B, so 1 black, 1 red, that means either one or the other, is probability of the first one plus probability of the second one. So that's my first equation. 1 ball red, 1 ball black, that means either first red and second black, or first black and second red. So if I calculate each one of those probabilities separately, when I add them, I will have the probability that 1 ball is red and 1 ball is black, which is what I want to know. Okay? So let's calculate the first probability here, this one. First ball red and second ball black. First red and second black. Okay, we have property number 6, which talks about what happens when you have A and B and 2 events that might not necessarily be independent. They could be dependent. Now in this particular case, actually, they are dependent, but this property covers everything, any kind of 2 events. What is the chance of A and B? It says the chance of A and B is equal to the chance of A time the chance of B given that A has happened. Okay, so let's apply that. So it says first red and second black, that should be equal, according to the property number 6, probability of the first red times probability of the second black given then the first one is red. Okay, so I'm having two events, first red, second black. If I want to calculate the first red and the second black, that is first being red time the probability of the second being black given that the first is red. That's a property number 6. Okay, what's the chance that the first ball is red? That's easy, 2 out of 3. You're drawing the first ball, it's going to be 2 of them are red, 1 of them is black. 2 out of 3 is the probability the first ball is red. What is the chance the second ball is going to be black given that the first one is red? So after you draw the first ball and that one is red, so this one is gone, let's say this one, what do you have left? You have 1 red, 1 black. What's the chance you're going to have a black when you draw second time around? 1 out of 2. So probability of second black given that the first one is red is 1 out of 2. I just need to multiply this. 2/3 times 1/2 is 1/3. Just a basic story about fractions. And I can cancel 2 and 2, you get 1 out of 3. That's the probability here, this one. Okay? Now I'm going to calculate the second probability in this sum. This first ball black and the second ball red. First ball black and second red. What's the chance of that? Again, I'm going to use the property number 6. Property number 6 says that if you want to find what is the chance of the first black and the second red, it's a 2 events, right? First black, this first event, second red. So this is 1 event and the other event. The property number 6 says that's the same as the probability of first black time red given then the first ball is black. Right? So again, I'm just simply using the probability number 6. It says A and B is the probability of A times the probability of B given that A has happened. Right? So again, probability the first one is black and the second is red is the same as probability the first one is black times the probability the second is red given that the first one is black. Okay, so now we can calculate either one of the both of this probability. Probability the first one is black of this probability. Probability the first one to 3. 1 is black, 3 balls. So that's 1 out of 3. The chance of having a first ball drawn to be black is 1 out of 3. Now the chance the second is red once the first one is black. So the first one is drawn and that's black. Now what is the chance you're going to have in the second drawing red ball? Well, only red balls left, 2 of them. So that's 100% or 1. Probability could be 1, right? So that's our probability here. Right? If you multiply 1 and 1/3, of course you're going to get 1/3. So the chance that first ball is black and the second ball is red is 1 out of 3. Okay? So now we have this probability. All right? Now when I usually ask people and they say, well, it's going to be 50-50. No, it was 2 out of 3 chance that you're going to have drawing 2 balls out of this hat, that one of them is going to be black and one of them is going to be red. So the chance that you're going to have both red is 1 out of 3, because that's a complementary probability. If you're not going to have 2 different colors, the only other way you can have it is both red, right? You can't have 2 black because there's only 1 black ball. Right? Then we just find that out. Now if you don't believe that, you can do experiment. Make a box. I mean, you can find a box. Now if you don't have a balls, maybe you can get a table tennis balls and just write on it, red number 1, red number 2, black number 1. You don't have to color them. Put them in a box and draw at random. Twice, first ball, second ball. You can grab 2, but so you can draw first ball and second ball and see what you're gonna get. You have to do that like maybe I don't know, 1,000 times, and you will see 2 out of 3, 666, 667, or something close to that. It's not necessarily gonna be precise, but something close to that will be 1 red, 1 black, and 1 out of 3 times is gonna be both red. Okay. Now, if you don't have balls, you can write on a piece of paper. I mean, black, black. I mean, red, red, black. Put it in a hat and draw two pieces of paper. The same story. Okay. You can do that. If you do that, many number of times, you will see what we call law of large numbers. You will see this is actually exactly what's going to happen. Okay, so the probabilities does follow Kolmogorov properties. Okay, so what properties we did use here? We use property number 1. When I was talking about complementary events. So I was saying if you find what's the chance that one is red, one is black, then, and that was 2/3, then to have both of them red, it's going to be 1/3 because it's a complementary probability, right? Once you calculate one, you know the other. I was also using property number 3 because I said when you have one black and one red, that means first red and then black, or first black and then red, and they are mutually exclusive. So if you calculate one of them separately and then you add, which is exactly what I did, you get a probability of one red and one black. Right? You need their order. Also, I use the property number 6, and I said that's a very important property, right? And I use the property says that if you have A and B, then it's a probability of one of them, and then probability of another one, given that the first one happens. So you have to multiply that, and I used it twice. Okay. Now, another thing I want to point it out in this particular example that the first black and the second red are dependent events. So I want to point this out. The reason why I use the property number 6. First black. The event that the first ball is black. And then I have another event that second ball is red, right? These two events are dependent. You can also talk about the first being red and second being black. That would also be dependent. These two events are dependent, okay? Now, if the first ball drawn is black, okay? If you draw the first ball and it's black, the chance of getting second one red is 100% because the second ball, there are only two balls there and both are red, so it's going to be 100%. Now, if the first ball is not drawn black, so that didn't happen, that means that one of the ball that was drawn was red. And then the probability that the second one is red is going to be 1 out of 2 because you have one red, one black left. Okay? So drawing the first ball black, when that happened, that changes the probability of getting second red. Right? If this happened, then the chance of second being red is 100%. If this doesn't happen, if the first is not black, then the chance the second one is going to be red is 1 out of 2. Okay? That makes them dependent. So these two events are dependent. And that's the reason why I use the property number 6 here. Okay? Because I could have used the property number 5, but I couldn't really, because the property number 5 talks about two events that are independent. Property number 6 is more general. It talks about two events that could be dependent and could be independent. In the main lecture, the property number 5 follows from property number 6. So the property number 6 is more general. So if you're not sure whether events are dependent or dependent, independent or dependent, then you use property number 6 because it's general. The same thing about property number 4 and number 3. If you know that events are mutually exclusive, like I knew that two events are mutually exclusive, I use property number 3. But if you don't know that, if you're not sure, then you have to use the property number 4. So property number 3 talks about how to calculate A or B. Property number 4 and number 3 talks about it, how to calculate probability of A or B. Property number 5 and property number 6 talks about how to calculate probability of A and B. Okay. Very peculiar, right? This is I think, very interesting part of mathematics. Probability is very interesting. You have to really think. Okay. So this is just an extra example to give you some idea why those properties are important and how we can actually use them. And of course, down the road, I'm going to also teach you another way to calculate the same thing here. So there is the alternative that we can calculate the probabilities I was calculating here in this example. So what is the chance that one of them is red, one of them is black? This is another way to do that. That will not use property probabilities, but use something else, like counting. But that can only be used if you can count. Now, if you have the situation in which you can count, now how many outcomes you can have here when you are drawing two balls, you can count. You can get this one and this one, you can get this one and this one, you can get this one first and this one, you can have this one and this one, and you can have this one and this one, in that order. So you draw first one, this ball, and then second one, this ball, that's one. You can draw this one first, and then this one, that's two. You can draw this one first, and then this one, that's three. Yeah, and you got both red in both cases, but I mean, it's a different situation. If you draw this one and this one, that's four. You can also this one first, and this one, that's five. And you can also draw this one and this one, that will be six. Interesting, right? 6 different ways you can get that two balls. Anyway, what I'm saying here, if you can count, there is another way to calculate that too. So we're gonna do that down the road, but I'm not yet ready to talk about it because it's gonna be something that we need to learn before. Okay, but you can use property probabilities, and that doesn't depend on counting at all. Property probability holds whether you can count or not, doesn't matter, right? So this is an extra example. So I hope it's interesting to you, and hopefully you can think about it a little more on your own, right?